We are up again, and this time we have Joe Coburn with us talking about microservices with Flask. Welcome.
All right, we'll kick this off. Thank you for joining me, everybody. It's my privilege to join and give you this talk, and especially to have the last talk of the first day. It's been a great day so far. I've enjoyed lots of talks, and I hope you have as well. I'm just curious where you're all watching from. I know we've got people from the UK, from Ireland, from the USA, so happy Independence Day to you American folks, and from China. I believe there's more. I've seen a few more in the chats. I myself, I'm from England, so it's 7:30 p.m. here, a lovely evening here in the countryside. But, oh crikey, that's almost 5% of our time gone. So I'm going to get a move on. So yeah, we're going to talk about lessons learned building microservices with Flask. So I'm going to cover what microservices and why we at ScholarPack use Flask and why we chose microservices. But I'm not going to do any live demonstrations, but we're going to cover a few things which you may find useful if you do microservices with Flask. So today we're going to learn what microservices are, how Flask is perfectly suited to creating microservices. We're going to look at some cookies with It's Dangerous. We're going to look at Flask Alchemy for databases. We're going to look at Flask Limiter, and we're going to look at unit testing Flask. And then there's a couple of extra bonus tips thrown in there for good measure. So who am I? I'm Joe, probably know. I think I know a few of you on the stream right now. I'm UK based and a senior developer at ScholarPack, and we'll cover what ScholarPack is very shortly. Up until very recently, I was a editor and writer at Make Use of Tom, and I'm a fan of all things Python. I'm an author of an upcoming Flask book titled Build Your Own Car Dashboard with a Raspberry Pi. And I run Flask on a Raspberry Pi inside a car, and I'll show you how you can do that and how unit test it, test-driven development, and start from scratch. And there's some links, so if you want to grab me on Twitter or GitHub, that's the easiest way to contact me. My phone will just buzz and I'll probably reply very quickly. What is ScholarPack? Well, ScholarPack's the company I work for, and we're a UK-based cloud MIS supplier. So an MIS is a management information system, and they're used in the UK to manage pupils in schools. So teachers track things like attendance, what lunches the students are having, where they live, so they can contact their parents if there's a problem, and things like that. And it's a very safe market because all UK schools have to have one of these systems by law. And it's a bit like changing your bank account. People don't like changing. So once you have a customer, they're a very loyal customer. So it's a very safe market. And we're part of a much larger company called The Key, who provide education resources. So most of our stack is a legacy monolith in Python 2, but all our new services are Python 3.7, and they're almost exclusively Flask or Pallets tooling, such as Click for smaller services. And we have a few modules on GitHub. You can find us at github.com/ScholarPack. And over the coming years, we're rapidly increasing our open source offering, and we're looking to open source some existing packages, which you may find useful, so do check us out. So as for ScholarPack Tech, we experience a peak load of roughly 65,000 requests per minute, and our external facing APIs are only roughly 8,000 requests per minute on average, in addition to the 65,000. This is through 10% of UK primary schools using our system. And it's a really interesting pattern because every day during the week, everyone comes on at 9 AM and 1 PM to register their students. By law, you have to, as a school, you have to know if your kids are there for the morning and if they're there for the evening. So every single user logs on, fills in a little bit of a form, checks their students in, and then most of them log off again. A few do some reports, but so we get this huge spike and then it tails off. And then overnight, weekends and holidays, there is no traffic at all. Nobody uses the system. So it's a very interesting pattern. So our legacy monolith is Python 2.1 or 2.4 even for most of it, is self-managed AWS EC2 instances with no auto-scaling. And then our new Flask microservices are AWS Fargate auto-scaling instances. And some instances, some of our legacy services use Flask to self-scale. We found that we couldn't scale quick enough, even with AWS, to meet this huge spike at 9 and then nothing. We just couldn't scale quick enough based on the criteria we needed. And we use AWS Firecracker virtualization. That's much quicker now, but it's still not quite fine-grained enough for us. So this is a really rough diagram of our microservices I drew yesterday. It's probably not accurate at all. You could probably combine 2 or 3 of these diagrams and smash them together, and you'd be closer to the chaos of microservices. But it gives you a rough idea. We have various services talking to each other, talking to databases, going through internal APIs, external APIs, authorization, and so on. So here we go, skipped a slide there. So what are microservices? For those of you who don't know, this is called a microservices architecture. And it basically splits an application into multiple small services. So it may not work for you, and I'm not quite going to get into the pros and cons of microservices, but it works really well for us at ScholarPack, where we can have independent scaling requirements for different systems, because everybody needs to log on every day, but some things they only need to do once a year, or only a subset of users run once a week or once a day. So we have vastly different scaling requirements, and without microservices, it's much more difficult to scale up. You have to scale up the whole system, the whole database, when you just need this little component to grow. And so when designed properly, you have these nice loosely coupled services. That's the way you want to do it. You don't want really tight dependencies between services, and you should be able to manage, even if it's in limp mode, by losing this service over here, it shouldn't have a knock-on effect on this service. And that can increase your resilience. But it kind of, if you know your computer science, and this is what I briefly discuss in my book, the single responsibility principle is really important here. So you want your service to have one defined task. So you don't necessarily want, say, a student service, because the whole product is about students. But we could have a registration service, an authorization service, where one component handles one major aspect of your product. And if you want to know more about microservices, I can highly recommend Sam Newman's book. It's called Building Microservices, Designing Fine-Grained Systems, and he covers far more of the details around microservices. So why Flask? Well, it was a really simple choice for us. It's quick and easy to learn, as we'll see in just a second. It gets out of your way. It has no opinion on how to solve problems, which is something we really like. It doesn't say you have to do it this way, you have to use this database connection. It just says, well, I'll just work with whatever you've got to use. It's free. There's a massive community, as we can see now. A Discord blowing up in the chats. We've got YouTube, we've got Twitch, there's video tutorials, there's Stack Overflow, there's books. There's a huge array of tools, packages, books, community, and it makes your life easy. That shouldn't be underestimated, how easy that will make your life. So this isn't going to be a live coding challenge, but this is what I call the 30-second microservice with Flask. So on the screen, we can see all the code you need to build yourself not just a microservice, but a Flask app. So on the left, we have a file. You can call this anything you like. I've called this app.py. So we start by importing Flask, which is a fairly standard Python pattern. And then we create ourselves an instance of Flask. So we haven't used the application factory here, and that's fine for this example. So once we have an instance, we can use the decorator to define a route, which is where you're going to access this page in your URL. And then we have a function, and then we have some works. In this case, we're returning hello FlaskCon. And all of this, by the way, is available in depth in the URL on screen on the Pallets link. But once we've done that, we can save that file. Then inside our terminal, we can export our app, which is an environment variable Flask needs to run, and then we can run Flask. And that gives us something like this. We can see Flask is telling us some stuff. It's saying it's running, this is a file, it's running with a production environment. but it's also giving us a very important warning that we probably shouldn't use this for production. At ScholarPack, we run Unicorn and we have load balancers and various other bits, but for local development, this is absolutely fine. So then at the bottom, we can see Hello FlaskCon. So that is it. That is all you need to know Flask. There's lots of other things it can do, but in 1, 2, 3, 5 lines and then 2 lines of bash, you're running a Flask application. That is all there is to it. And that's why we love it. But there's always a but. We have this concept of a Flask skeleton. So it is incredibly easy to run. But if you're running in production and you're running microservices, there's various other bits you have alongside an application. So you definitely want logging. In our case, we have signed cookies. We have a database connection sometimes. We have unit tests and integration tests, and we build pipelines and all these things. So they may not be so quick to configure. So we have a skeleton, which is a pre-configured Flask app for our needs. So it has all this stuff in, which are standard microservice needs. And when we need a new service, we just fork our repo and we're basically there. We may have to remove a database connector for certain uses, or we may have to add application logic, but this gives us our Flask app with everything we need ready to go. We fork it and we're basically done. We can start writing the application code and stop wasting time rebuilding all the stuff we've built dozens of times before. But it's very important to keep this up to date. As you work on new packages, as you figure out better ways of doing things or new things become available, go and update your skeleton. So one of the things we have for our microservices in our skeleton is cookies. So we use It's Dangerous, which is a brilliant Pallets tool for sending data between untrusted networks. So it cryptographically signs data so you know that the contents haven't been tampered with and you can trust the thing that sent it to you is what you really thought it is. And it's the perfect way for microservices to communicate, obviously, with that little asterisk there that you should do other security measures, but we're not getting into a security talk just here. And we can see the example URL for a It's Dangerous example, but in 10 seconds, here we go. I'm going to race along here because we're rapidly running out of time. We can just import the signer from It's Dangerous, create ourselves an instance with a secret key. And now this is a pre-shared key. So our microservices, the sender and receiver, they're both aware of this. So they don't need to say, oh, I used this key or whatever. And then you can sign your string. And then as you can see, the string is in plain text. So you don't want to send sensitive data. It's not encrypted. But by unsigning that, you can cryptographically be certain that you can trust the data, you can trust the sender, because unless something's gone really wrong, nobody else has access to your pre-signed keys. And this is how we communicate between our microservices for our internal stuff. And we created what we call a cookie manager. So this is a tool we use with It's Dangerous to build all our signing stuff for us. It manages the keys and it pushes extra data into our cookies for us. So all you have to do is configure a cookie manager on either end, load it up with your keys, and then our microservices, they can all talk to each other. So moving on to databases with Flask SQL Alchemy. This is a very, very short slide, and I know we've had a couple of examples of this today, but Flask SQL Alchemy really easily connects Flask to SQL Alchemy, as you'd kind of expect with the name. It handles the sessions for you, it provides several utilities, it links it all up. For example, on the screen we can see in one command, db.createAll, we can create our whole database schema based on the models. Although this isn't necessarily Flask SQL Alchemy. It's very simple to use, and you can see the 2-minute quick start at the Flask SQL Alchemy docs, which are linked on the screen, and we will revisit this when I share the slides. Now moving on to Flask Limiter. This is, I've actually been doing a lot of work using Flask Limiter the last couple of days. This is the perfect way to rate limit your services, especially Flask services. So our external APIs, we have other integrators want to use our data. So sometimes this is a sign-in system where you a kid's late and they can touch the screen and move data into our system, or a payment system or email system. There's various other education suppliers, and they all want to talk to ScholarPack, talk to our system. And so we use Flask limiter to limit our external API. And so every integrator, every single one, are rate limited to 600,000 requests per day. And this is a paid for API. And they always hit the limit. They always say, can we have more? Can we have more? And we say no. But Flask limiter just handles this with no problem at all. We run a Redis-backed rate limiter so that we can share our rate limiting across different instances as we scale, and as different things happen or restart, we don't lose our rate limiting. And over the last year, we've had well over 3 billion requests rate limited through our API. And Flask limiter has not given us a single problem at all. We just love using it. And then in 2 lines, we can see this is a really quick example of using the rate limiter. We just import the class again. I'm sounding like a broken record. We import the class, create ourselves an instance, and we're basically done. There's some other decorators you can use, but by default, it just knows what a Flask route is. It knows how to apply its limits, and it just does it. Very importantly, it doesn't limit your static assets. So we just love Flask limiter. It's so easy to use, and it's incredibly stable. So moving on to unit testing. If you're not unit testing, why not? It's really the first piece in your testing arsenal. And if you're worried about, oh, well, Flask is hard to test, it's perfectly possible to test. We have dozens of Flask applications we have unit testing in. And really, depending on how you code, you may not even need to do any Flask wrangling for your particular use case. But it's really important to understand the Flask application context. So Patrick Kennedy gave a great talk today entitled Demystifying Flask Application and Request Context with PyTest. So I'm not going to repeat that, but that recording will be up shortly. But in this 30-second example, we've got a PyTest fixture here. And in order to access Flask specific stuff where, say you were in a request and Flask does stuff, or it needs access to your logger or a running Flask application, this is how you can test that sort of logic in your unit tests. So all you have to do is create yourself a testing Flask app, and then we have to push an application context. And now from that point onwards, providing we have access to this object, which in this case with this PyTest fixture we do, we can now access and run our application as if it was running on its own Flask app, but we're inside our unit tests. So if you've been afraid of unit testing Flask or your applications, then again, 5 lines with PyTest and an application contest, and you're ready to go. And then finally, this is a bonus slide because it is too good not to include. But there's a Python library called Helium, which is a wrapper around Selenium, which is a testing framework, a very powerful but very heavy testing framework. And in my opinion, this library is the best way to start integration testing. And many people, our present company, ScholarPack included, we have hundreds of unit tests, but we're very lacking in integration tests. But that doesn't have to be the case because Helium makes it so easy to integration test in Python. And it works perfectly in Flask. So here we go, in 5 lines again, 30 seconds, we import some functions, we start our browser, driver equals start Chrome, and Firefox is also supported, unfortunately not Internet Explorer. We can go to our URL, which in this case is the Flask application running from the previous slides. And then we can do some assertions. We can do anything we like here. We can click buttons, we can enter text. In this case, we're going to read that hello FlaskCon exists on the page. And then we're going to kill the browser. And that is it. That is an integration test in 5 lines. And they don't need to be complex. And this works perfectly with Flask. So if you're not using that, I encourage you to look it up. It will save you an incredible amount of time. And I believe that means we're just about out of time. Any questions?
That was awesome. That was super cool. Thank you so much for that. So yes, we have one question now on Discord. Jurg is saying, great talk. The legacy system has to be Zope. How do you communicate with Zope? Zope has no built-in REST API.
That's a very good question. Yes, I've seen a few people know Zope on their Discord today. But we actually do a lot of stuff to separate, kind of keep Zope there as this legacy system. And then we have our microservices. And so we actually built a reverse proxy in Python and Flask. And so when you come in to our application, you actually go through a Flask application first. And that decides where to route you. It looks at the URLs and it actually does some regexes in Python. And it says, right, I'm going to route you to Zope. I'm going to route you to this microservice. And then as for our APIs, we don't actually touch Zope for that. We have an API microservice, which has an OAuth 2 server with it, and that's in Flask as well. And that just has its own connection to the database. So we have to maintain Zope, which does some work, and then we have to have a separate set of models which also may have to overlap on some logic, and that is we've decided we're going to go with that because we have 60,000 files in Zope, roughly 10 million lines of code. It's quite a lot of spaghetti code, and we use an older version of Zope which has acquisition, so we are in quite a pickle with it. And so that is why we're switching to Flask. It's not practical to just suddenly rebuild everything, but where we need new stuff, we just build a new Flask microservice, and then it's very easy to just have a button, which links you in to the new service. So from the user's perspective, it's just all one system.
Cool. Thank you for that. And then from the YouTube channel, we have a question. So is how do you manage service discovery?
Is that where is to a question? Okay, so I'm not too sure on what you mean on the question. I think I can answer it in terms of what automated discovery. I'm going to go with that angle. We are quite, I guess you could say we're quite old fashioned in that we are we're getting strong in the marketplace. 10% of UK schools use us, but we're still trying to keep ourselves quite lean. And we were formerly a startup, maybe, I don't know, I've been at ScholarPack 6 years now. We've probably been going 10 years. So when I started, we were very small, and we still haven't quite struck the balance between growing and employing. So here in Lincolnshire, it can be quite hard to recruit at times. We're an hour away from some big cities, Nottingham or Sheffield. So if you want a big salary, there's very little reason to come to Lincolnshire. So one of the things we struggle with is DevOps teams. We're recruiting for those right now, if anybody would like a DevOps career. And so we don't really have any systems which discover services. And in terms of our users knowing what services exist, they don't really need to know. Essentially, we just have our application, our reverse proxy, which is, you could almost say it's hard coded with routing rules. So whenever we bring a new service online, we have to create a new routing rule, which will route you in. But there's almost always a user will have a button, or they have a report or something which will lead them into the service. They don't have to know what services exist or think, oh, I need to go here. They just think, oh, I'm going to press this button I've always pressed. And it may be one day that it suddenly takes them to the new service instead of going to the old service. I hope that answered your question. Do feel free to DM me on Twitter if you would like some clarity. That's the best I could answer, I believe, in one sentence.
Perfect. Well, thank you very much for that. So yeah, he was trying to clarify on YouTube, but I think David kind of answered the question like a little bit. So yeah, but anyway, please do feel free to contact Joe on Twitter or anywhere else to clarify your question. And then do we have time for another one? Just a quick one.
Yeah.
So do the servers communicate over HTTP only, or do they use anything like Kafka or Rabbit?
Well, it depends on the service. We have a lot of stuff going on. The bulk of our current services use HTTPS solely with its dangerous cookies. And for the most part, they're just saying, I am this particular school. And then when the service receives it, it knows what that person is. If it needs to go to the database, it can pass that information to the next service, for example, an internal REST API. We do have a couple of queues for some bigger jobs. So we use Redis for some queuing, which will pop entries into, there are some FIFOs, but mostly they're lists now. So they can say, hey, we need this data. And then some other service will poll that and say, okay, I can do that work. I can make it so. But yeah, for the most part, we're trying to get stuff to work with either running as a daemon or just its dangerous cookies.
Cool. Perfect. I think that answers the question. And I think that also finishes the time. So thank you very, very much for joining. Thank you very much for your talk. Thank you for everyone that is watching as well on YouTube and Twitch. This ends then the first day of FlaskCon 2020 first edition. And thank you very much, David, for all your hard work and for helping to host as well, for everything. Thank you. Thank you. And yes, that's it. So that's it for tonight. Thank you very much.
Yeah. Just a reminder, you can go to FlaskCon.com to see the schedule and get the links tomorrow when we start the stream again in 19 hours, I think.
Something like
Trying
that.
to do 24 minus 5 hours for talks. Math, you know. But yeah, go to FlaskCon.com to get the links to everything, get the schedule. Join us tomorrow.
That's it.